Dear students, welcome back. In the previous session, we have discussed about compensatory lateral lean of the trunk. Okay, now in this session, we are going to discuss about use of cane contralaterally. Okay, so when the cane, we have also find some values when we use the cane ipsilaterally in the previous session only, but use of a cane ipsilaterally will cause us some reduction of energy, but the total hip joint compression is greater than the lateral trunk lean. Okay, so now we will see use of cane contralaterally, how this will have effects on the supported hip joint or affected hip joint or painful joint. Okay, when a cane is moved to the side opposite to the painful or weak hip joint, the reduction in HAT is same as that of for ipsilateral usage. That is, the superimposed body weight is reduced by 25 lb of downward thrust. Okay, downward thrust approximately 15% of the body weight. Okay, to 125 lb in our 180 lb individual. However, we now have the cane substantially farther from the hip joint. Now it is very much farther than from the hip joint. Okay, then it would be used on the same side. So that is, in addition to relieving some of the superimposed body weight, the cane is now in a position to provide a counter torque to the torque of the gravity. Okay, now we are going to calculate, already we have calculated in the previous session, that is the gravitational adduction torque of 500 inch lb we have noted for a body weight of 125 lb. Okay, now estimating an average momentum of 20 inches in between the downward thrust of the cane. Okay, this is this distance I am now explaining. So the estimating an average of momentum of 20 inches between the downward thrust on the cane and to the supporting hip joint, okay, the cane would generate an opposing torque of how much now? Okay, so how much the torque is produced now? So torque is 20 into 25 lb. So this is the weight weight is transferred to the arm and to the cane. This weight you have to take in. Okay, now how much torque it is? 500. Okay, so 500 inch lb. So this one is same as the torque which is produced on the affected hip joint or supporting hip joint by the gravity, that is gravity adductor force. So both the forces become equivalent, both the torques are become equivalent. Okay, completely eliminating the need for a hip abductor force. Okay, isn't it? So normally if it is producing some amount of torque, gravitational adductor torque, so the adductor should produce some counter torque here. Okay, that one is reduced now by using the cane on the contralateral side. Okay, yes. Here the hip joint reaction force without a necessary contraction of the hip abductors would be only that imposed by the body weight itself, or 125 lb. Okay. But here the classic description of forces using a cane on the side opposite a hip joint disability as presented number of studies. However, some of them we can going to discuss in that. So the question raised in this case is how the downward thrust of the arm on the cane actually acts on the pelvis. One thing. Then the equilibrium of an object such as the pelvis can only be affected by forces actually applied to that object. Okay, the explanation of use of the cane lacks some cohesiveness if the force cannot be explained in terms of a force applied to the pelvis. Okay, although they propose that the force of the downward thrust on the cane arrives on the pelvis through a contraction of the latissimus dorsi. So the downward thrust on the cane arrives on the pelvis through a contraction of the latissimus dorsi. How it happens? So as we already know that this latissimus dorsi is a depressor of humerus through both its humeral attachment and it is more variable scapular attachment, and has been classically defined this muscle as crutch walking muscle, since the downward thrust on the cane is accomplished through the shoulder depression. Okay, just as crutch walking, it is logical to assume that latissimus dorsi is active. And also if you see the attachment of latissimus dorsi, so it is getting originating or attached to the posterior iliac crest. Posterior iliac crest. So it would create an upward pull on the crest on the side of the cane. On the side of the cane. So such kind of movement is that is the downward thrust is caused by this latissimus dorsi. An upward pull on the side of the pelvis opposite to the supporting hip joint axis creates an abduction torque around the supporting hip joint. And now this force is creating an abduction torque on the affected side. So then the magnitude of latissimus dorsi muscle contraction should be approximately the same as the downward thrust on the cane, under the supposition that this muscle initiates the thrust. Although measures of the momentum of the pull of the latissimus dorsi on the posterior iliac crest are not available, we might estimate that the line of pull is directly above the acetabulum. Above the acetabulum. So since the gravitational force is estimated to lie 4 inches from the supporting hip joint line, the line of pull of latissimus dorsi should lie about 4 inches to the other side of the LOG above the opposite hip joint axis. Okay, so on the right side, the LOG from the joint axis, it is 4 inches, what we have seen in the past. Then this one also having the same distance from the LOG to the joint axis. So now totally how much it becomes to the supporting limb? 8 inches. Then we can find this what you call as the moment arm. of pull of latissimus dorsi is estimated as 25 inches into 8, that is 200 inch lb. Okay. The abduction torque of the latissimus dorsi muscle can then be estimated as 200 inch lb. Okay, that is this is 8 into 25 lb. So we have taken the entire distance 4 plus 4. So we got how much? 200 inch lb. Okay, now it is more accurate estimate of the effect of the cane held in the hand opposite to the painful or weak hip. Some contraction of the hip abductors, is needed now. Okay. Given the estimated 500 inch lb adduction torque created by gravity, okay, 200 inch lb would be counteracted by the abduction torque of the latissimus dorsi, but 300 inch lb of abduction torque would still need to be generated by the hip abductor muscles if equilibrium is to be maintained. Given the 2 inches in momentum of the abductor muscles, if 50 lb contraction would be needed, that is 300 inch by lb by 2 inch, that means we get 300 inch lb by 2. Okay, so this still it requires some abductor force, that is 300 inch lb by how much distance? 2. So then we find 150 lb. Okay, 150 lb of force contraction would be needed, so for maintenance of the equilibrium of the pelvis. Okay, so now what will be the total hip joint compression would be? So as we know that 125 lb body weight compression and the abductor compression now is 150 abductor force. So this one is latissimus dorsi. So this thing we should not take, we should not consider. So this latissimus dorsi is creating an upward thrust which is creating some force and which is transmitting the superimposed body to the arm and to the cane. So that one we should not consider here. So we have to consider in the total hip joint compression. So we have to consider the abductor force, how much which is created at this supported limb you have to take. Okay, so that will come to 150 lb. So total amount is total compressive force on the joint is 125 lb. So why? Because some of the weight is transferred to the contralateral side, and the abductor force which is created by the hip abductors is 150 lb. So the total one you will get 275 lb. That means this 275 lb, which is lesser than the amount of what you can call as joint hip joint compression, which we have estimated in the ipsilaterally used cane. There it is 375, now it is 275. So much of difference we have seen by using a cane in the contralateral side. So here we have got both energy reduction as well as hip joint reduction. Finally, we can say that use of cane on the contralateral side is better than use of cane on the ipsilateral side. And also somewhat this 275 lb is still greater than that compensatory movement of lateral retrunk, but we can reduce the energy changes and we can reduce the stresses on the lumbar spine. Okay, so that means we can maintain a good posture by using this contralateral side use of cane. Okay, so this is all about the function in the unilateral stance. Okay, so in the next session we are going to discuss about hip joint pathology. Thank you.